We hear the term autonomous drone all the time, but what does that really mean? I'm not just talking about a drone that follows some GPS points on a map. I mean one that can actually think for itself. One that can make smart, human-like decisions on the fly when things get messy. It's a massive challenge, and it turns out the solution is to teach a machine to think a little less like a computer and a whole lot more like us. So let's get into how that actually works.
All right, here's how we're going to break this down. First, we'll dig into the core problem every single autonomous drone has to deal with. Then we'll look at the really elegant solution, which is something called fuzzy logic. After that, we'll peek under the hood and see how this drone brain is actually put together. And finally, we'll check out the pretty incredible results and what it all means for the future.
So, to really appreciate just how cool the solution is, we first have to get a handle on the problem. I mean, why is it so incredibly hard for a drone to just navigate the world by itself? Well, it all comes down to the limits of thinking in just black and white.
This is the million-dollar question, right? A drone's environment is just chaotic. It's anything but predictable. You've got sudden gusts of wind, you've got unexpected obstacles, a bird, another drone, a tree branch, all while its battery is draining and maybe its GPS signal is getting a little shaky. And here's the kicker. It's dealing with all of this at the exact same time.
And this is where traditional computer programming just hits a wall. See, computers are built to think in binary. It's either a 1 or a 0, yes or no, true or false. But how does a drone answer a question like, is the wind a little too strong? Or is the battery getting kinda low? The real world is full of these shades of gray, and that demands a totally different way of thinking. So how on earth do you teach a machine to see those shades?
Well, that brings us to the solution, this amazing concept called fuzzy logic. It's basically a way for a machine to reason about its world that goes way beyond simple yes or no answers.
Okay, the best way to think about it is like this. Binary logic is a regular light switch. It's either all the way on or all the way off. There is absolutely no in-between. Fuzzy logic, though, it understands ideas like a little bit on or mostly off. It works with degrees of truth. It can handle answers like maybe, or a lot, or not so much.
So in a nutshell, fuzzy logic is a dimmer switch for a computer's brain. And that flexibility, that ability to operate in the space between absolute on and absolute off, that is exactly what a drone needs to handle all the complex stuff the real world throws at it.
So, okay, the theory of fuzzy logic is super cool. But how do you actually use it? How do you take this idea and build a functioning brain for a drone? Well, first, the system is constantly pulling in data from 7 key inputs. It's not just looking at one thing. It's aware of everything, all at once. How far away is that obstacle? What's my battery level? How fast is the wind blowing? What's my own speed? How good is my GPS signal? What's my altitude? And, maybe most importantly, how critical is this mission right now?
Then, the decision-making process kicks in, and it's a 5-step dance. First, it senses all that data. Then comes the magic part. It fuzzifies it. That means it translates a hard number, like battery at 15%, into a useful, human-like concept, like battery is low. Once it has all these fuzzy ideas, it runs them through a really complex rulebook of if-then statements. And finally, it defuzzifies the result, turning that conceptual decision back into a concrete command, like slow down by 2 meters per second, and tells the drone to do it.
And here is a fantastic example of what one of those rules actually looks like. I mean, look at that. This isn't a simple command. The system is juggling all these competing factors at the same time, a close obstacle, a low battery, strong winds, and high speed, and it makes a sophisticated, almost intuitive judgment call. Slow down. That's the kind of complex reasoning you'd expect from an expert human pilot. So the theory is really powerful, and the design seems smart. But does it actually work? Well, to find out, the researchers put this new brain through an intense virtual proving ground.
And they didn't just test this a handful of times. They used what's called Monte Carlo simulations, which is basically a fancy way of saying they threw hundreds and hundreds of different, really challenging scenarios at the drone, over and over, each time with slightly different conditions. This is how you really put a system like this through its paces and see if it holds up.
So how did it perform? Well, let's start with the most important job, not crashing. The system achieved an obstacle avoidance efficiency of over 82%. Think about that. Across more than 900 different challenging flights, it successfully dodged the vast majority of things thrown in its path. That's a huge deal for making drones safer to use in our world.
But it wasn't just safer, it was also smarter. because it was making these more nuanced flight decisions, no more jerky, sudden movements, but smoother, more calculated adjustments. The fuzzy logic brain cut down on energy use by a solid 8%. That means you get longer flight times and can get more done on a single battery.
Okay, but this number right here, this might be the most impressive one of all. The decision accuracy of this fuzzy logic brain was over 95%. That is an insanely high level of reliability. It means that when faced with a complex choice, almost every single time, the system made the right call.
And what's really remarkable is just how consistent these results were. If you look at this chart, it doesn't matter if they ran 300 scenarios or pushed it all the way to almost 1,000. The performance barely budged. That high level of avoidance, the energy savings, that incredible decision accuracy, it all stayed rock solid. This proves the system is genuinely reliable, not just a one-time fluke.
So these results are obviously pretty amazing, but let's zoom out for a second. What does this all mean for the big picture? Why does this research actually matter for the future?
Here's the bottom line. Fuzzy logic isn't just some small upgrade. It's a game changer. It gives us drones that are fundamentally safer, way more efficient with their power, incredibly reliable in their decision-making, and most importantly, actually smart enough to handle all the messiness and uncertainty of the real world.
This work is definitely pushing the boundaries for autonomous drones for sure. But it also opens up a much, much bigger question. If we can teach a drone to reason with this level of nuance, what other really complex jobs, things like self-driving cars or even robotic surgery, could we one day trust to machines that can think in shades of gray?